Hey there, my gorgeous friends on the internet, and welcome back to another episode where we solve a bunch of Leetcode problems. How fun is this? I started this series last week, and I'm so happy to see that everyone's so excited about this. I could never imagine. So I'm really happy for that because I love doing these, and we're essentially going to go through everything here from zero to hero, right? We're going to start off with hashing and arrays, which is what we covered in the last week with the 3 simple problems. But today we're going to up the level a little bit to 2 intermediate problems, but we're still going to stick to hashing and arrays until we build up a really, really good intuition. So if you like this, there's one little thing I ask from you, a little scrub and a little scrub. How about a sub? That would be even better. Okay, cool. So let's get going. So the first one that we are going to look at here is going to be the grouping anagrams. Now, we did in the last episode, we did solve an anagram one. If you don't remember, what we did is it was a simple one. So we just simply had 2 strings that we needed to compare. So you can imagine we have 2 strings, eat and then t, right? And an anagram is basically, you can basically move these characters around to create the other word, right? So if I take the T here and move it there, and if I take the E and move it in the middle, I get T, right? But if this is something like teal, then there's no way you can get eat, only eatle, which is weird. Okay, so that's one, but this one is a bit more complicated. Grouping anagrams here, let's have a read. Given an array of strings, strs, group the anagrams together, you can return the answer in any order. So we have the strings here, eat, tea, tan, ate, nat, and bat. And we essentially want to create what's called a 2D array here. So it's basically an array within arrays, inception style basically. So you got bat here, right? Because it's not an anagram to anything else. And then you group together all the anagrams, right? It's as simple as that. So how can we approach this? Well, the first thing is how we did it in the last one. If we have a look here, is we created a hash map, or in TypeScript in our case, it's called a map, and it's been added in ES 2015. Oh my God, that's 10 years ago. Holy smokus. But what we do is, you're going to hear the word frequency a lot. And essentially what you do is frequencies is you count, right? You essentially count and see how many things are in each string, how many characters are in each string. So how does a map look? Like, you can also do like an object. It's essentially a key value pair. So you have a key, which is like E in this case, right? And then you have a value. So you count how many E's do we have in here. So 1, right? And there's 1 E, so 1. And then you do the same for A as well, and the same for T as well. And then what we did in the other one is we essentially check to see if this map here is equal to another map that has basically the same key value pairs. And if it is, then it must be an anagram, right? But this example is a bit more complicated. So how do we approach this? So the intuition is right here. We should use frequencies, but it's just going to look a tad bit different. So first of all, let's create a map here. We'll need this as well. So we'll say new map, and I'll add a little generic here so we can have this typed. So I'm going to have a string for the key, and the second is going to be an array of strings. So this is actually going to store the groups here. So this, right? That's going to get added here. Okay. So we need to go through each word, right? So how do we do that? Well, when you need to go through something, just think loop, right? Every time. So we can do a normal for loop. We can do a for of. We'll do a bit of both. How about that? So let's do for. We can say const string of strings, right? Let's open this up. And what I want to do here is create that frequency. Now, how is this going to look? Well, this problem in particular only asks for characters that are lowercase, basically, right? There's no numbers in here, uppercase characters. So we can basically cover A to Z. So that's 26 characters, if I'm not mistaken. So we can create this like frequency variable here, and I'll just create a new array. So let's create a new array, and we'll give it the length of 26, like that. And we can also fill it up. So let's fill it up with just a bunch of zeros, right? That can be like your indication of like how many stuff is in there. So you can imagine like you have a frequency, right? A bunch of zeros like that. And each of these represent, like, we're all making this up, right? We're all cuckoo land here. So we can represent these any way we want. But I can say, well, the first 0 here is A, and the B, C, D, right? All the way to Z, right? And then if we detect like 3 A's, then we can just increment this up to 3, right? And that's your frequency, and that's something that we can use to compare. So there we go. So we did that, right? We got that. That's great. And here, now we want to go through each individual character. So here, console log str, this represents each string. So if I run this, right, we got ET10, 8, perfect. Okay, so now we can take this str. Let's do normal for loop in this case. For let I equals 0. We do I is smaller than str length, the individual string, right? And then we can do I++, and let's open this up. Okay, so what do we want to do in here now? Well, we need to, there's a little cool thing here you can use, which is called this character code. This is like the ASCII character code. In ASCII, like each like value represents a certain, because you have like 0, 1, 2, 3, which are numbers, right? But you have special numbers that represent characters. So like 97 would be A, 98 would be B, etc., etc. So if you do something like this, let me show you. If I take the str here and we say character at, and I'll pass an I here, so that's going to look for the index in this string and get like the character code for it. So if I go and do a console log character code, let's hit save and have a look. We are getting, why am I getting that console logged out? Character code string at. Sorry. Okay, that's the character at. We need the character code at. There we go. And then I can pass in the I. Let's have a look at that. There we go. So, right, so E would be 101, A would be 97. And if I also just like console log out here the frequency for you, just so you can see kind of how this looks as well. There we go, right? So it's just a bunch of zeros for each of the strings. Okay, but 97 is a bit like not fun, right? That doesn't look too nice. So what we can do instead is we can represent A starting from the beginning, so from 0. Just a bit easier to do, right? A is 0, 1 is B, etc. So let's just say minus 97 like that. So if I console log this out again, run this, as you can see now it's a bit easier to read. So 0 here is A, E is 4. Okay, cool. And now what we can do, let's get rid of these console logs, simply increment that. We can grab that frequency and we can simply go at the character code, right? That's the position in our like thing that we drew out here, right? Character code C is this one. So we can go directly there and then increment that. So frequency code like that. And we can just say plus plus here. Let's just go out of this for loop here. If I console log out the frequency now, you'll have a good idea how this looks. There we go. I'm having heartburn, I'm sorry. Let's run this again and check it out. So look at that. For eat, all right, we incremented 1. So that's A, and then E, 1 there, and T, 1 there. So now we have a really nice representation of these anagrams. Now what we can do here for our hash map essentially is have this frequency as the key. So that will actually be our key. Like that, something like that, etc., etc. And the value here is gonna be the actual like string of the characters. So tan, nat, etc. Okay, so this is how we want to put this together. Now currently our frequency is an array of numbers. I just want to convert this over to strings. So frequency str, and I'll just take the frequency and say toString. Okay, just so we can save this as a key, a unique key essentially. So if I console log out frequency string right now, oops, Let's run this. There we go. So you get, this is basically a line of strings that we can use to set as the key. So let's just go here down below and we can add it to our map. So we can say let's do an if statement and firstly check if it exists there or not. Is this h map, let's do has, this just returns a boolean based on the key. So does it have this frequency string? Because if it doesn't, then we can insert it. Frequency string. There we go. If it doesn't have it, then we can say hmap set, and again we want to set the frequency string here as the key. And I'm just going to initialize the value originally as an empty array. Okay, so if it doesn't exist, create this hmap with this unique frequency and set the value as an empty array. Okay, so if we go down here and just do hmap quickly, let me show you how this looks. There we go. So there we go. So we have like this unique string now, right, as the key, and then it just sets all the values as empty strings. And the last step is we simply need to push in the strings into this hash map now. So we can say hash map, we can get this unique frequency string like that. And if it exists, we simply push it in the string. It's as simple as that. So if I just go out here, do a quick console log of the hmap again. Let's do that. Have a look. Look at that. It works, right? We got eat, t, ate, and bat. However, in this case, we only want the array here, right? We only want the value to be returned. Go here at the end of the line, and we can simply return. And the way you can do this is use array from, and this accepts like a map. You can just pass that in here. So we can say hmap, and you can get the entries here, which is going to return you both the key and the value. But in our case, we just want to get the values back. So let's return that, and let's try to run this. We can say lead test. It's judging. And there we go. Look at that. Case 1, case 2, and case 3 all passed. So we can finally submit it with lead submit, I think it's called. It is. Come on, let's see. And there we go. It's accepted, and it has a runtime of 36 ms. I also quickly wanted to give a shout out to this solution here that's incredibly fast, and I just thought it was so intuitive and so clever, and I wanted to let you guys know about it. So it's using prime numbers. So as you can see, the beats is 99.8. How crazy is that? So prime numbers are only divisible by themselves. So if you multiply them together, you can only reach the resulting number by using the same values. If you map the characters to prime numbers and the resulting total is equal, then there's no way it's not a anagram. So here's the approach. Look at that. Look at the runtime. Super, super good. And so here is how you kind of do it. You have your primes, so you just create a big array. You do convert strings to prime values. So you get the total here. You initially set it to 1. You do your loop. You get the character here. And then you can use primes here at character code 0. If you pass in 0 here in the character code, that's because the key here is already the character. So it'll just like default to getting the actual character code for it. If you actually have the whole like word, then you can pass in like 4 to go to that specific location in the string. But if you only have one character, then you can use 0 to just get it. And then all you do is total, you just multiply it by the prime number and then you return it. And then here it's as simple as converting it over to the prime value, and then again doing a check here, which I think is still using a map. It is number, yeah. So really cool solution. I wish I came up with that. It's really clever. Before we get into the next challenge, I want to give a quick shout out to a platform that I've been really enjoying lately. It's called Code Crafters. Look at that, we got the VIP. If you want to learn about web technologies, this is just such a fantastic resource to learn. And if you like Leetcode as well, they have stuff on like HTTP servers, building your own Git, making your own Redis as well. And the best part is that you get like the live feedback, kind of like Leetcode. So if I go here, for example, you get the test cases, so you can run the code as well. And if you're learning a new language, like I've been learning a bunch of C++ lately, so it's really cool because you can just go here and select the language of your choice. So you kind of get a 2-in-1. I do have an affiliate link down below if you want to give that a look. Helps the channel out a bunch. Just wanted to give them a quick shout out. Thank you so much. Let's get into the challenge. And if you're wondering what's the time complexity and the space complexity in this, it's basically O of n times m, where n here represents the strings in the array, which you're multiplying with the characters of each string, right? Alrighty, let's have a look at the next one. This one is called top k frequent element. So given an integer array of numbers and an integer k, return the k most frequent elements. You may return the answer in any order. When I first read this question, I remember exactly when I first did it. I had no Scooby what they were talking about. But basically how this works is you are given an input of nums, in this case 1, 1, 1, 2, 2, and 3. And if the target is 2, you're essentially returning the 2 most frequent elements in this array. So 1 is the most frequent one, right? That happens 3 times. Frequency, exactly. You're getting good at this, man. So 1, again, the order doesn't matter here. It says somewhere here, it says in any order, right? It doesn't matter if the 1's here and the 2 is there, but we will keep the order right because we're awesome. And I want to also show you a little bit of a sorting algorithm called the bucket, which is going to be cool. Okay, so if you pass in 2 here, you should return the 2 most frequent ones, right? So that's the most frequent one in this case, and that's the most frequent one. But you might have 1 element, and in this case, you just return the 1, which is fine. Okay, so how do we approach this? Well, we're going to create a map again, like we used to. HMap. Let's say new map. And in this case, I'm just going to do numbers here. We just want to count. If there's a bunch of 1s, then we'll put 3 here for the value, right? So new map, pass in the generic as well here. And we'll say number and number. Now the second thing I'm going to make here is something called buckets. Now let's create these buckets, and what this is going to be is a new array like that. Now what size do I want this array? I essentially wanted the size of the amount of numbers that I'm dealing with here. So it's going to be O of n, right? So 1, 2, 3, 4, 5, 6. So I can just do nums the length for that, right? 6. Perfect. So if I console log this out, run this, 6 empty items. Have a sip, stay hydrated, friends. We don't care about adding a value here yet. I just want to create this bucket for now. And then we're going to fill in the bucket based on, we can use basically the map to like dictate which numbers go on where. You're going to see it in just a sec. I'll write it out first and then we'll visualize it, okay? Okay, so we got the bucket. Now let's do a loop over all these numbers. I can do a for of, I don't think we'll need the index here, const num of nums. So for now, let's just do a check here to see if we have anything in that HMap. So if there's nothing in the HMap, we can do the has here. Again, that's just a Boolean that indicates if the element with the key exists in there or not. So we can check if the num exists in there. And if it doesn't exist, let's just set it to 0. So we can do HMap set and say num to 0. Otherwise, let's go down to the bottom here. We can do HMap set. I'm going to get that number again. And let's do a HMap get here. I basically want to get and see if the value is there. The num, and I'll do +1. There we go. It says it's possibly undefined. It'll be fine. Now let's just simply console log this out so we can visually see what's going on. So let's see what's in this HMap now. We could have also like renamed this HMap to our frequency, because this is our frequency. If we run this, look at that. We get the key of 1, right, has 3. 2 has 2, and 3 has 1. So we are on the right track. Okay, so that works. And now we simply have to like push in the values in this bucket. So the way we can do this is, what if we just push the higher frequency number up in the bucket and the lower frequencies a bit more down in the bucket? That would pretty much sort it out, right? So if we have a look here, we have 1, 3, 2, 2, and 3, 1. So if we have a look here, we can do, where's my pen? We have 1, 3, 2 of 2s, and 3 of 1, right? And our bucket looks something like this. It has 6 values. 1, 2, 3, etc., etc., right? So what if we just look at this, right? We can use this as our little keyword here, the value here, and basically the 1 here, right? We can say, well, this happens the most, so let's push this up highest in this bucket. And that's essentially what bucket sort does, right? You take the highest value here, so we can say index 0, 1, 2, 3. So let's put the highest at index 3, right? And then 2 has 2, so that would go here. And then 3 has only 1, so we'll put it in index 1. Sorry, the value 3 goes here, is what I meant. And then 2 is fine there. And here it actually should be 1. Sorry, there. And there we go. Now, again, we're looking at not like essentially like sorting the numbers in here, but putting the highest frequency number, sorting the highest frequency number in this bucket. And there we go. And that way we can simply just like cut and slice the last 2 here. And that should do the trick. So let's go here. At the bottom, we'll do for, another for loop. And we're going to say for, I'll do brackets here of the HMap entries. HMap entries gives you back both. Let me go here and show you console. We're learning so much about arrays here and maps. It's really fun. HMap entries. Okay, so if you do that, that'll give you back both like that. So and then a for loop, then you can kind of deconstruct these two. So you can say key value here. Let's open this up. But key value kind of makes it, I feel like, a little bit hard to kind of grasp what's going to go here, because what we're looking for here is the frequency, really. So that would be the frequency, and this would be the value, but it's weird to put the value here, so I'll just say this is the number, right? We have the number and the frequency as the second one. Oh, you gotta make sure to put constant here, otherwise it won't work. So there we go. So now we can simply get that bucket that we created, and we can look and go to that frequency. So the higher, right, would go more up on the list, and we can simply add in the number. So just set equal to number, and that should do the trick. So let's set the equal. Let's take this change in parentheses, and I'll just console log out the buckets to see what's going on. Let's head back here and run this. As you can see, we have empty, empty, 3, 2, 1. So the most frequent element is at the top, and the second most frequent is 2. So it works. Now we have a bunch of empty spaces here that we don't really need. So you can use something called a flat. So I'm going to say flat map here equals to, I'm going to take the buckets, I'm going to do flat. Cool. Let's console log this out again. I'll move this down here. Let's do flat map. Have a look, and look at that. We have 3, 2, and 1. So now all we need to do is simply return flat map dot, and if you remember, the thing we can do here is we can use slice, right, to just cut a portion of this array, and then we can do the nums, not nums length. What do we need here? Simply do the length of this flat map, the length, and we can minus the k, the target that we're looking for, right? So if we want 1 number, 2 numbers, etc., etc. So I'll do k. And there we go, that should be working just fine. There's one little caveat I actually forgot here, is what if the buckets, the numbers that we're passing here are 0? We should always have like at least one empty space. So I'll add +1 here. And there we go, let's try to run this. Let's say lead test. And there we go, case 1 is accepted, case 2 is accepted as well. So let's try to submit it, lead submit, and that should be it. So there we go. Hope you enjoyed this little episode. Oh no, we have a wrong answer. Expected 1, 2, output is 2. What did we miss? So if num's 1, 2, and k is 2, the output should be 1 and 2, but we're getting 2. So let's give this a go. I'll just do a test case 2 here and check this out. Stop k frequent. I'll pass in 1 and 2. And then the target here should be 2. Let's see what we get. Console log T2. Let's run this. Okay, we get 2, so something is not working correctly. It must be the slicing. If we head over here, let me just console log this out. I want to see if this still returns correctly here, and it's just our flat map. Console log flat map. Let's go here and run this. No, it's 2, so there must be something above here that gets messed up. I think the issue is here. Have a look, since we're just like pushing in the number and we have our buckets here as a single array, see? But we should make it actually a 2D array here because the values can get overridden here. So as you can see, if the frequency is, sorry, if the number is the same, it's simply just going to get overridden here. So 1 gets set here, but then it gets overwritten. So what we can do is let's just head over here to the top. Instead of our buckets being a simple 1, let's do this instead where we set this to 0, and then I is smaller than buckets.length. I++. All we simply want to do here is get the buckets I and set that equal to an empty array. All right, so we have little buckets now in there. And rather than doing frequency set it equal to a number, let's just get rid of that and now simply push it in. So the format is going to change just a tad bit. Push in the number. So there we go. That's just a little update there. Instead of overwriting it, we're just pushing it in. Let's give that a shot now. We'll say lead test. All right, there we go. It passed. And let's also try to lead submit this. And there we go. So there we go. That was the little problem here. And the space complexity for this is O of n. And let me just console log out so you can see how the buckets look now. So if I do the buckets down here, let's run this. So it's going to look like this. In this case, the problem was, as you can see, it's overridden it because we're positioning on the frequency base, right? So in this case, it was the middle one here. And we added 1, but we set it equal to the number. So it's just overridden with 2, right? And then now when we call flat, all of these are going to get deleted. So there we go. Awesome. Well done. Thank you so much for watching and joining me on this episode. We'll probably stick to doing a couple more of these until we get really comfortable. We're going to amp up the shanty or the ante, whichever you want. And I'll see you guys in the next one. Peace.